Log on, tune in, find out. Another good idea from Cambridge.
We are very grateful to Professor Peter Clarke for coming back to the Faraday course. He's a regular actually at our Faraday summer courses to come and talk to us about the brain. As you can see from our program, we're switching gears today to talk about the brain, free will, brain imaging, all those sort of topics. And so we're very grateful to Peter for coming back yet again and helping us on this topic. He's in the Department of Cell Biology and Morphology in the University of Lausanne in Switzerland. He actually did his PhD with somebody who I personally think was one of the sharpest minds in this country, certainly, and maybe internationally, in the science religion field in the course of the 20th century, and that was the late Donald Mackay, who possibly Peter may allude to during his talk, but a very sharp professor, a neuroscientist interested in perception and vision and those kind of brain communications. So Peter has a wonderful background to address us this morning on whether the brain is a neuronal machine. So thank you, Peter.
Thank you. Well, maybe I should be qualified to talk about machines because I began by doing a degree in engineering and then went to Donald Mackay to study neuroscience. And people sometimes say, well, how can an engineer give lectures to medical students? And sometimes there can be misunderstandings between engineers and medical doctors. And once an engineer and a medical doctor and a politician were discussing together, and they got into a debate as to who played the most important role in the creation of the world. And I'm afraid yesterday's speakers forgot to mention this important debate. But the medical doctor said, well, I played the most important role because how could God have made a woman out of the side of man unless he had the help of a medical doctor? And then the engineer said, look, you haven't understood anything about it. That wasn't the creation of the world. That was long after the creation of the world. Right at the start, there had to be the creation of order out of chaos, and for that you needed an engineer. And then the politician said, yes, but who created the chaos?
Peter, I don't know if your mic, is your mic switched on? It is on.
Sorry, no, I forgot to switch it on. That's probably just as well.
Yeah.
Okay. So my subject, the brain is a neuronal machine. And the problem is that if religion and faith, and indeed all our thoughts, emotions and actions, result from brain activity, which is roughly what most neuroscientists believe, and if our brains are then neuronal machines, what follows from that? So we'll first look at the evidence for the brain being a kind of neuronal machine. And this goes back to people like Alcmaeon of Croton and Hippocrates, who on the basis of mainly clinical observations, people who'd had head injuries, came to think that our thoughts and emotions were linked to the brain. And Hippocrates wrote, men ought to know that from the brain and from the brain only arise our pleasures, joys, laughter and jests, as well as our sorrows, pains, griefs and tears. Through it in particular we think, see, hear and distinguish the ugly from the beautiful, the bad from the good, the pleasant from the unpleasant. It is the same thing which makes us mad or delirious. Madness comes from its moistness. And when people know that I come from England, they think, oh yes, madness from the moistness. So that was the 6th century BC, and then the 5th century. And then also the mechanistic approach also has very ancient roots. And for example, Democritus explained all physical and psychological processes mechanically by the movement, collision, joining and dissociation of atoms. And he thought of the soul as a physical entity being composed of the smallest atoms. And he argued that the soul moves the body. And here you can see him laughing. And he may have been the first person to be taken to the cognitive behavioral therapist. I'm looking at one in the back there. And his friends thought he was mad because he was laughing all the time. And so actually they took him to Hippocrates. And they said, look, we got a problem. Our friend is mad. He's laughing all the time. And Hippocrates said, he's not mad, he's happy. And well, I don't know if Martin has therapy for people who are too happy. And then we're going to jump a very long period to Descartes. who, as you know, made the analogy between the body and the brain on the one hand, and a hydraulic machine on the other. And he thought that all animals are hydraulic machines, in which the driving fluids are what he called animal spirits, but animal spirits were a very physical thing, flowing through tubes. He thought the nerves were the tubes. And he thought that, so animals were just hydraulic machines, whereas human beings were different. Human beings had a rational soul, which would somehow interact with the machine in the pineal gland. And his ideas were moderately controversial. I mean, he had to leave France, but almost anyone who had ideas had to leave France. But his ideas were only condemned by the Catholic Church after his death. They were not extremely controversial, only moderately so. But at his time, there were people who disagreed, and even before, because Galen, who was, well, at one stage he was a medical doctor for the Emperor of Rome, and he came up with the idea of animal spirits, and he considered this idea of Descartes, that somehow the animal spirits might interact with the soul in the pineal gland, and he concluded that he rejected the idea, which he said was ignorant and stupid. And then at the time of Descartes, there was the Princess Elizabeth of Bohemia, who was, no, I forget, the daughter of, was it James the First? Something like that. Yes, I think she was daughter of James the First of England. And she wrote, "I confess that it would be easier for me to conceive that the soul has matter and extension than that an immaterial being has the capacity of moving a body and being moved by it." So she disagreed with him, and after a considerable exchange of letters, he advised her that young ladies should be advised not to think too much about these difficult questions. It might be bad for their health. But then the real debate, the real anger, the uproar came with Julien Offroy de la Métrie, who wrote the famous book Man Machine, L'Homme Machine in French, of course. And in that book he wrote, "Let us boldly conclude that man is a machine." So to say that animals were machines, that was okay, but to say that man was a machine, that was a real problem. And he had to leave France, as so many thinking people had to. But then even in tolerant Holland, he was still considered too controversial, and he had to flee to the court of Frederick the Great of Prussia. But only a few years later, when Baron von Holbach, who was German but lived in France and wrote in French, when he wrote the Système de la Nature, it was not very controversial. These ideas had started to be acceptable. He wrote, "Those who have distinguished the soul from the body have merely distinguished the brain from itself." And he was a popular person in the French Salon in Paris, where there were many intellectuals, including people like David Hume. And this notion of man-machine, that is still very much in the minds of most neurobiologists, and here are some popular books. In French there's L'Homme Neuronal, and there's the Cerveau Machine, or in England written by Colin Blakemore, who was for a time in Cambridge and then went to Oxford, Mechanics of the Mind Machine. And there are many other books with linking together the notion of brain and machine, mind and machine. Now, why do we think all that? The brain seems to be a kind of neuronal machine with no need of a separate soul, because the brain is made of neurons and other cells. The cells are made of atoms and molecules, and the atoms and molecules obey the laws of physics and chemistry. And the same with a machine. A machine is made of parts, it may be transistors or other parts. The parts are made of atoms and molecules, and the atoms and molecules obey the laws of physics and chemistry. What's the difference between the brain and the machine? And then also the interactions between the cells and the parts. obey the laws of physics and chemistry, which are almost deterministic apart from subtle quantum effects, and the brain activity appears to underlie all our conscious experience and to cause all our behavior. So what's the difference between a brain and a machine? And the brain underlies our consciousness. Now let's just look a little at some of the evidence for that in very rapid detail. Here on the left is a neuron with its axon, its output wire, and it's going to communicate with the next neuron, and it's going to release, when an action potential, a burst of electricity comes down the axon, it triggers these vesicles will fuse with the membrane and release their contents into the synaptic cleft, which will influence the next cell. And here we have the synaptic cleft and these vesicles at much higher magnification. And there's a picture of a synaptic cleft, and you see these vesicles. When the electric burst of activity gets into this thing, the synaptic bouton, that causes calcium to go in. The channels open, the calcium goes in, and the vesicles are held close to the membrane by various proteins, including one called synaptotagmin. And when the calcium binds to the synaptotagmin, that changes its shape, which causes the vesicles to be literally pulled against the membrane, and it fuses, and then this causes a hole, and the neurotransmitter molecules, these red things, come out, and they bind to receptors on the next membrane. And when they bind, that opens little holes in the membrane called channels, and then ions like sodium and potassium can flow in and out, and that changes the potential in the next cell. So that's how it works. And of course I'm simplifying a bit, and it's all very mechanistic. Some of this work has been done on simplified situations like neurons in culture and that sort of thing. And I once went into the office of a colleague who works on this, and I said, your work is all wrong, because in your cultures you don't have the soul. And of course he roared with laughter, and there was no danger of him taking me seriously. And incidentally, here we have a synaptic cleft. It's actually a connection with a muscle, not another neuron, but it's the same principle. And you can see some of these vesicles actually fusing with the membrane, and you can imagine the neurotransmitter molecules coming out. Now, I mentioned the electrical potential of the cell. There are equations to calculate this, and here's a man who invented one of the most important equations. Here's his equation. I'm not going to go into detail, but this is just to mention that he actually derived this equation in his research on batteries, and the same equation turned out to be useful for studying cells. It's all very mechanistic. And then this notion that brain activity underlies all our conscious experience and causes all our behavior. Well, you've probably all seen hundreds of pictures of brain imaging. In this case, it's a PET scan in which you put in a radioactive substance, and then the active parts of the brain get a bit more of the radioactive substance into them. And so when you're hearing, the lateral part of the brain gets activated. When you're seeing, the back part of the brain. When you're speaking, this part on the left. When you're thinking, in other words, planning in advance and so on, part of the frontal lobe gets activated. And of course you can go into much more detail than this, and we will be having a talk from Alistair Coles on brain imaging. And so he will talk about brain imaging even for religious activity. But you can say, well, okay, that's just correlative. When we think, when we see, when we hear, our brain gets activated, but this doesn't show causality. But if you stimulate the brain, you can promote movements or thoughts. And this goes back to Edward Hitzig. He actually, when there was a battle between Germany and France, he found some patients on the battlefield who'd had parts of their skulls blown away, and it wasn't very ethical in my opinion, but he had his electrical stimulator and he just went and put it on the brains and stimulated to see what happened. And he produced some movements. And so he decided he'd like to work on this, and so he teamed up with his friend Gustav Fritsch, and they wanted to do some experiments on live dogs in Hitzig's home. But unfortunately he didn't have a laboratory, and so he did the experiments on his wife's dressing table. And when I got married a long time ago, I said to my wife, who happens to have a very good knowledge of the history of neuroscience, and I said, "Do you want a dressing table?" And she said, "No." And then some good things were done in Switzerland, and Walter Hess was one of the people who stimulated the hypothalamus. So that's a human brain, and the hypothalamus is this region here, just below the thalamus. And he stimulated it in cats, and he found that according to the particular part of the hypothalamus he stimulated, he produced anger or fear, at least behavior suggesting anger or fear, or thirst, or hunger, or sex activity, or sleep. And then Wilder Penfield did similar experiments on humans at McGill University Hospital in Montreal. He unfortunately, with epileptic patients, you usually can control the symptoms with drugs, but occasionally you can't, and then you have to do operations. And he was going to have to do some operations to remove parts of the brain that were causing epileptic fits, and he wanted to find out as much as he could to remove the part of the brain that he should remove and not healthy parts. And so he had the patients under local anesthesia in the operating theatre, so they were just sitting down, conscious but with their head open, and he stimulated the brain, and he found that if you stimulated the motor cortex, he got movements. If you stimulated the visual cortex, he got flashes of light and so on. And in other parts, the person seemed to be experiencing something like that. They're yelling at me for doing something wrong. And in the temporal lobe, he produced complex memories. Someone said, "I'm in an office somewhere, I can see the desk, I was there, and someone was calling to me, a man leaning on a desk with a pencil in his right hand." And the patient said that this was not like a sort of memory, it was more real than a memory. It was as if he was actually experiencing this, that the person was there calling to him with a pencil in his right hand. And on one occasion he stimulated the right side of the brain near the temporal lobe, and the patient said, "Oh God, I'm leaving my body." So he had an out-of-body experience. And so all this could be produced by stimulating the brain. Now, the notion that the brain should somehow underlie our humanity, our personality, our thoughts, our actions, that's disturbed a lot of people, both atheists and theists. And here's a quote from Francis Schaeffer, who many of you probably know. He wrote, "The modern scientists insist on the total unity of the downstairs and the upstairs." By upstairs he means the spiritual, the aesthetic, the human. By downstairs he means science, logic and reason. And the upstairs disappears. Neither God nor freedom are there anymore. Everything is in the machine. We find they include in their naturalism no longer physics only. Now psychology and social science are also in the machine. So many people have found this notion a problem, and that's really my subject at the moment. And to be more precise, if the brain is a machine, this raises several problems. What about the soul? What about free will? Are we just machines? And does the machine analogy undermine our spirituality and our humanity? Well, first, what about the soul? I think still, if you go to the average man in a Clapham omnibus and ask him what he thinks, he will think that there is a thing called a soul that somehow interacts with the brain. And that goes back to Plato. So Socrates in Plato's Phaedo says, does not death mean that the body comes to exist by itself, separated from the soul, and that the soul exists by herself, separated from the body? And many Christians have adopted this view. It's called a Neoplatonist view, because it goes back to Plato, and Origen, Augustine. With Aquinas, it's not so clear. He said the soul is the form of the body, and there was some debate on exactly what this means, but probably Aquinas didn't accept this Neoplatonic view. But Luther and Calvin did, Descartes did, Western folk philosophy. But that doesn't mean that all Christians have accepted this view. For example, Austin Farrer, a great Anglican theologian who wrote a book on free will, he wrote, we will have nothing to do with the fantastic suggestion that what the supersensitive reactors in the cortex react to is the initiative of a virtually disembodied soul. He was writing about a book by Sir John Eccles, a neurobiologist, who claimed these ideas of supersensitive reactors being influenced by a disembodied soul, and Austin Farrer totally disagreed with this view. He thought that the Bible doesn't teach a disembodied soul. And indeed, in the Old Testament, now I'm going to say a little bit about this, but I believe that Mark Cortez will be saying more and much deeper. He's a theologian this afternoon. But just briefly, the word most commonly translated soul in the Old Testament is nephesh. Its primary meaning is life or vitality, or movement. A great range of meanings. And in Genesis chapter 2, when God breathes on man and he becomes a living soul, or in other translations, a living being. And in Genesis chapter 1, God makes the great sea monsters and every living creature that moves, and the word creature is a nephesh. So this word doesn't carry the meaning of a Neoplatonic soul. It has many meanings, and it can be translated soul, but not in the sense of Plato. And then the word for spirit in the Old Testament is ruach, which has the idea of air in motion, wind, breath of life, and so on. But even when it is translated spirit, it has the idea of the vitality of the mind as expressive of the whole personality, or human inclinations and desires. It doesn't have the ideas of Platonic, of Neoplatonism. But I hope Mark may tell us in a more authoritative way what the biblical teaching is. And then in the New Testament, it's a bit more complicated because at the time of the New Testament, Platonism was very influential. There were other Greek influences as well, which were noticed sometimes, but the words tended to have dualistic overtones. And the word psuche, which is the New Testament equivalent of nephesh, again has a range of meanings from life and desire to the whole personality. And we must remember the New Testament doctrine of the resurrection of the body is very far from the Platonic concept of an eternal and immaterial soul that floats out of the body at death. Rather, is the idea of a resurrection. We'll have a new body, a resurrection body, as Paul discusses in 1 Corinthians chapter 15. And the notion of the soul being immortal is not really what the New Testament teaches. 1 Timothy 6 says God who alone is immortal. So nowhere does the Bible teach the notion of a disembodied eternal soul. In the words of J.K. Howard, man does not have a soul, he is one. Well, okay, that we may accept that, but there's still the question, what determines my identity? For example, if I go to heaven, and I don't have an eternal soul that floats off to heaven, but maybe you accept the New Testament notion of a resurrection, a recreation of a new spiritual body in some sense. by what criterion will this be the same me? But it's worth remembering that even in our earthly bodies, continuity of matter is not necessary for continuation of identity. In our bodies, in our brains, there's continual turnover of cells and molecules. And the important thing is the maintenance of an informationally relevant structure. Just as a poem retains its essential qualities, if it's retyped, if it's photocopied, even if it's copied out by hand in a different handwriting, that doesn't matter. It's the same poem. And we can take the analogy of transferring a computer program to a new computer. If you have a program and you install it on a new computer and then you destroy the old computer, you've destroyed the body of the program, if you like, but the program can continue to exist in a new computer. And it might, of course, be transferred to a better computer. The program might work even better. And I believe that when in heaven I'm recreated as a new and spiritual body, it'll be the same me, but on a better material support. Now, although Neoplatonism had a tremendous influence, I'm not denying that, nevertheless, it would be wrong to think that all Christians, until recently, were Neoplatonists. For example, in the debate between La Mettrie and Holbach, La Mettrie and from Holbach, they were monists. They didn't believe in a separate soul. But it turned out that many of the Christian experimentalists they argued against dualism more often than they argued for it. So it wasn't the Christian dualists against the anti-Christian monists. It was more complicated than that. And Joseph Priestley, who was a British nonconformist minister, the famous one, I'm not allowed to say this in the French-speaking world, but he discovered oxygen. And I think I'm not allowed to say it in Scandinavia, right? There's someone in Scandinavia who got there before Joseph Priestley. But he maintained that dualism between matter and spirit was due to the contamination of biblical Christianity by Greek philosophy. And he objected to the idea of an immortal soul because it rendered the doctrine of the resurrection superfluous. So, although Calvin and Luther and many other great Christians were Neoplatonists, they didn't have a total monopoly. Now, why did La Mettrie's books raise such a scandal? Well, it was partly because of the strong influence of Cartesian dualism and more generally Neoplatonism. Augustine was a Neoplatonist. And dualism was taught officially by the Roman Catholic Church, although this is a complicated question because the dualism of Thomas Aquinas was also official, and he was probably not a Neoplatonist. But and it's worth thinking that most of La Mettrie's arguments were not really against Christianity, but against dualism. And in some ways, La Mettrie could be considered the intellectual heir of the British empiricists like Bacon, Locke, and Newton, who were all Christians. So this is complicated. It wasn't atheistic monists against dualistic Christians. And then La Mettrie adopted Boerhaave's doctrine of iatromechanism, the notion that the body is a machine, and he attacked rationalists such as Leibniz and Wolff. Leibniz, I call him a rationalist, not in the modern sense of the word rationalist, but those who used thought as the fundamental basis of their beliefs rather than experiment. And von Haller, discussing this problem, where Hobbes doubted and Newton believed, where an Offrey, in other words La Mettrie, scoffed and Boerhaave worshipped. So they were all experimentalists, or at least people on the empiricist side, and Newton and Boerhaave were devout Christians, whereas Hobbes and Offrey or La Mettrie were not. Now we come to another question, what about free will? If our brains work mechanistically, then our behavior must be predetermined, so how can we be free? How can we be responsible for our choices if they were predetermined before we made them? How can we be responsible for our behavior if it was determined not by ourselves, but by the impersonal laws of science? And there are 3 or 4 kinds of answer. One answer is hard determinism. So yes, determinism is true, and that's incompatible with free will, so we don't have free will. And a few people hold that view. Most don't want to label hard determinism nowadays, but there are some philosophers who are pretty close to this view. And then there's compatibilism, which says there is no problem. Free will and determinism are compatible, hence the word compatibilism. And so compatibilism says that the 2 are true, and almost all compatibilists also think that determinism is true, and so they're sometimes called soft determinists. The term comes from Spinoza. They accept the deterministic premise but defend human responsibility. And here's a quote from Johnson Laird: "Any scientific theory of the mind has to treat it as an automaton. This is entirely consistent with the view that people are responsible agents." So that's compatibilism. And then libertarianism, which is the view that's really intuitive for most people. If you haven't read a philosophy book, you're probably a libertarian. And libertarians argue for indeterminism. We do have free will, and that's incompatible with determinism, so somehow we must have something indeterminate in our brains, and very often they evoke some sort of quantum chaos. But I won't go into that in detail because of lack of time, but fortunately we do have a talk at 11 o'clock on free will. Now, I will nevertheless say just a few words about free will. There are problems in defining it. For example, Albert Einstein wrote, "I can't understand what people mean by free will. I feel that I will to light my pipe and I do it, but how can I connect this up with the idea of freedom? What's behind the idea of willing to light a pipe? Another act of willing." And this is, of course, still a debate among philosophers. And most people link together the notion of free will and responsibility. Of course, you always find philosophers who disagree. That's almost the definition of a philosopher. And so there are some exceptions, but most people do link free will to responsibility. That's part of what they mean by free will. And it's worth noting that there are very different definitions of free will, and the definition you choose is going to be linked to what you believe about this question of whether free will and determinism are compatible. So here's a compatibilist definition: the power of making free choices unconstrained by external agencies. This is from the Free Dictionary. Note the word external. Whereas here's the libertarian definition, which I found in another dictionary, Handbook of Psychological Terms. Free will is the choices which are said to have no necessary determination from the nervous system or from any other physical cause. So this definition, it's no necessary determination either from inside or from outside. The compatibilist says he puts the emphasis on external agencies. And our choice of a libertarian or compatibilist approach may depend on our assumptions about the brain-mind relationship. If you're a neo-Cartesian, like Sir John Eccles was, a neurobiologist, Nobel Prize winner, if you think that somehow the soul is influencing the brain machine, then you've got to have some indeterminism in there so that there's enough liberty of action for the soul to influence the brain and change it. But if you're a monist, if you think that the soul is embodied in the brain, if you think the soul is a bit like a computer that's installed, a program that's installed in a computer, the soul is installed in the brain, and not a separate thing that acts on the brain, then you may want a deterministic brain, a machine without loose screws. But that's not always true. Some of the leading philosophers who promote libertarianism are monists and nevertheless propose an indeterministic brain. So maybe we'll hear a bit about that at 11 o'clock. But I'm going to have to leave this fairly soon because I've got a lot of things to say. But just since the least intuitive notion to most people is that free will and determinism could be compatible, I'd like just to say just something to explain why compatibilists think that external influences, external determinism, is different from internal constraint. An external constraint, I smashed the window because my sister made me do it. She pushed me. It wasn't my fault. I think most of us would accept that. It's not my fault, I was pushed. But how about internal determinism? I smashed the window because my brain made me do it. It wasn't my fault, my brain made me do it. Well, that's it. It's at least a different kind of statement. Because if my brain didn't make me do it, then I certainly wasn't responsible. So how can you say that I wasn't responsible because my brain made me do it? It's certain an internal determinism or constraint is different from external constraint. But there are still problems, and I think we'll be hearing about these at 11 o'clock. There are lots of problems. This is a very simplistic beginning to the subject of free will. Now, what about the question of, are we just machines? I think my approach, and that of many people who thought about this, would be that, okay, in a sense, maybe we're machines, but we're not just machines. And this is the view of David Chalmers, for example, who wrote The Conscious Mind, and he introduced a catchy term, the hard problem of consciousness, as opposed to the easy problems of consciousness. And by the easy problems, he means, well, they're not that easy, explaining what the brain does to enable us to discriminate, report mental states, focus our attention. Everything, almost everything that neuroscientists are trying to do is to solve what David Chalmers calls the easy problems of consciousness. So they're not that easy. But it's easy because all that's required is to specify a mechanism that can perform the function. If I can recognize a pattern, I've got to find a mechanism that's active in my brain that enables me to recognize the pattern. At least we know what we've got to do, even if it's complicated. But the hard problem is explaining why we have qualitative phenomenal experiences. The word for that is qualia. And philosophers talk about zombies, and when they use the word zombies, they mean people. In principle, one might imagine someone who's exactly like me, who's saying exactly the same thing I'm saying now, and if you looked in the brain of this being, you would find exactly the same thing, and yet that person would not be conscious. How could you tell a real person from a zombie? And this is the sort of thing that philosophers discuss, and indeed it is very hard to know how you can finally give a definitive answer to these questions. So are we just machines? Perhaps not. There is something more to be said about consciousness, about qualitative experience that can't be captured in a purely mechanistic explanation. And then another thing that we need to think about is levels and reduction. Attempts to explain the whole in terms of the parts have been seen as devaluing us. Your love for God or your boyfriend is reduced to the impersonal activity of neurons in certain parts of the brain, and because of this, opponents of science decry its reductionism, and some opponents of religion go to the other extreme and try to explain it away in terms of mechanistic science. But to face up to this, we need to understand these concepts of levels of description and clarify the idea of reduction. And here's a quote from David Marr, who did much of his most important work in Cambridge. this Cambridge, and then he went to MIT, the other Cambridge, to work on artificial intelligence. And he was really one of the founders of artificial intelligence. I think I should give a definition of artificial intelligence. I apologize in advance to any blondes here, because my daughter, who's blonde, said that artificial intelligence is a blonde who dyes her hair dark. But anyway, David Marr wrote, almost never can a complex system of any kind be understood as a simple extrapolation from the properties of its elementary components. If one hopes to achieve a full understanding of a system as complicated as a nervous system, then one must be prepared to contemplate different kinds of explanation at different levels of description that are linked, at least in principle, into a cohesive whole. So he wasn't arguing for a religious position at all. He was arguing from the point of view of someone who's trying to develop artificial intelligence, and he said, you've got to do this if you're going to make any progress. Now, what do I mean by levels of description? Well, supposing you've got a message on a blackboard, lecture cancelled owing to bubonic plague, for example, and you can have several levels of description. You can give maybe a Cartesian coordinate for each grain of chalk. And that's a complete description of the message. Or you can give an intermediate level, a list of all the letters, which you can just copy it. But maybe not in chalk, maybe in ink on a piece of paper. It's the same message, although not physically identical. Or you can just have the meaning. So there are these different levels. And the criterion for hierarchy, what do I mean by high or low? You can change a low-level description, for example, by moving the grains of chalk a little bit, without changing the message. But you cannot change the message without changing the chalk. So that's what we mean by high and low-level descriptions. Now, when we're talking about a body and a brain, and maybe even a human being in social relationships, you can have low-level descriptions and higher and higher and higher level descriptions, right up to social relationships. And many levels are needed to describe people or groups of people. Now, if you could describe every single atom in my body and say where it was, in principle, you would say everything you need to know to know about me. But this wouldn't be very useful. It would be very difficult to understand this description, and to at least have an intelligible description, you need to have a higher level description. And so we're talking here about the level of reduction, and there's actually a lot of debate about reduction, and there are many kinds of reduction. You may have seen the book of Nancy Murphy and Warren Brown, Did My Neurons Make Me Do It? Warren Brown spoke here at the Faraday Institute a couple of years ago. And they give 5 different definitions of reduction, 5 types of reduction. So it's a complicated business, but I think at least at the level I'm talking now, we must accept that all these different levels are valid. Now, among my scientific colleagues, I mean, no one would deny what I'm saying, but then they might say, yes, but this is the level which actually merits research grants. So they say that all the levels of description are valid. You can be a social scientist, that's fine, but actually, if you want a large research grant, then you should be at the level of molecules. I remember I was once in a committee meeting, planning a biology meeting in Switzerland, and all the other people in the committee meeting, they were cell and molecular biologists, and they all proposed that we should have talks and symposia on cell biology and molecular biology. And I said, shouldn't we have a little bit of system biology as well? And the president said, oh no, that would lower the standard. So there is a bit of chauvinism, about people liking their own level, but nevertheless, I think all scientists admit that all these levels are necessary. And a physicist is not going to say, oh, we could close down the molecular biology labs. because, or the chemistry labs, because we can do it all at the level of quantum physics. And then the opposite notion is emergence. As the system gets more complicated, different properties can emerge. Like if you've got one planet, then you can't say much about gravity. But if you start having two planets, or a sun and a planet, then you can describe orbits. One goes around the other. And if you've got one, so you've got an emergence. You've got a new kind of phenomenon emerging as the system gets more complicated. So emergence is really the opposite of reduction. So that, I've given a few of these definitions. I don't want to get too complicated on this. So reduction is an analysis of a complex entity into its component parts, understanding its workings in terms of its interacting components. And a term to remember is nothing battery, a term invented by Donald Mackay. And he gave the example of someone who goes and sees a beautiful painting in an art gallery. And he's admiring the painting, and then a chemist comes in, and the chemist says, this is nothing but atoms and molecules. And then the man who's just admiring the painting says, but it's beautiful, there's a sunset, there's a beautiful woman, there's a sky, there's a tree. And the chemist says, look, if you take away all the atoms and molecules, you will find there's nothing left. Now, of course, no one would really be so stupid. And the debate is not whether there are other things than atoms and molecules. The debate is whether there's another level of description which is more relevant, which is more interesting, more important in the case of this beautiful painting. Now, there are many kinds of reduction. In science, there's methodological reduction, analyzing the whole in terms of its parts. And a great deal of science is doing this. But we're not going to say that because we can analyze a neuron in terms of its parts, its molecules, and so on, therefore we don't need the concept of a neuron. And I think I'm going to jump this, except to say that I was once in a committee which were evaluating people for a prize at Oxford University. And actually the woman who won the prize, who wrote a very good essay, it was on biochemistry, and in the interviews she said, well, everything comes down to biochemistry in the end. And one member of the committee who worked on birdsong said, you mean the biochemistry of birdsong? And she said, yes. Well, maybe you can study the biochemistry of things that are going on in a bird that sings. But I think that most people who work on birdsong think there's more to be said about birdsong than what a biochemist could say about it in terms of biochemistry. Now, this last subject, well, okay, we may accept that a machine kind of description is okay because there are other things that can be said as well. Man is a machine, but he's not nothing but a machine. Okay, but isn't the machine analogy a bit dangerous? And here's B.F. Skinner, you probably know, one of the great names of behaviorist psychology. And he wrote, man is not made into a machine by analyzing his behavior in mechanical terms. Man is a machine in the sense that he is a complex system behaving in lawful ways. Well, I think that's fairly valid, but I would point out that that's not what most people mean by a machine. And this is a very general notion, and if you're using such a general notion as this, then I think one can say man is a machine, a complex system behaving in lawful ways. But that's not always the way machine is used. And here's Horace Barlow, who was also a famous neuroscientist at Cambridge, England. And he wrote, most scientists accept the machine as a useful metaphor or model of the mind. I have been forced to the conclusion that the metaphor is misleading and potentially harmful. But this results from prevalent ignorance about machines rather than any gross defect of the metaphor. I think that Barlow's right. If you say man is a machine, you start thinking, well, he's like a sort of very sophisticated washing machine, a very sophisticated car, and the moment we start using the word machine, that evokes all sorts of notions that are unhelpful and indeed degrading for man. Although if you use the word to mean a complex system and behaving in lawful ways, maybe it would be okay to say that man is a machine, although not just a machine. Now, on this question of the machine analogy, I thought I'd end by talking about the machine in relation to what the Bible has to say about man. And a machine is made by a creator for a purpose, and the purpose is decided by the maker. And according to the Bible, man was created by God for a purpose. For example, Ephesians 2:10, we are God's workmanship, created to do good works. The purpose was decided by the maker. And for a machine, at least in practice, the knowledge of the parts is not sufficient to understand the function of the whole. You've got to have the different levels of analysis to understand the machine. And that is true for man too. And the machine is usually made according to a blueprint. For those who are not native speakers of English, a blueprint is a sort of design specification. And according to the Bible, man is the blueprint is Christ. Romans 8:29, those whom God foreknew, he also predestined to be conformed to the likeness of his Son. I find this rather moving, the notion that even though I fall so far short at the moment, my ultimate destiny is to be like Jesus. And then a machine can break down. And the breakdown is defined in terms of the purpose. And so for a Christian is broken down like a broken down machine if he doesn't fulfill his purpose, which is not to run 100 yards in 10 seconds. It's to be like Jesus. And so, in those terms at least, I think I'm a broken down machine. And then a machine can often be repaired. And in Christian teaching, the breakdown is so radical that the repair is referred to as a new creation. If anyone is in Christ, he's a new creation. So this mechanistic description is not totally at odds with the sort of thing that the Bible is saying about human beings. And so to conclude, what about the soul? The Bible does not teach a Neoplatonic dualist doctrine of the soul, although many Christians have been Neoplatonic dualists. What about free will? Well, compatibilist and libertarian approaches may both be compatible with theism, and we'll probably hear more about that at 11. Are we just machines? Beware of the error of nothing buttery. We may be machines in the sense that Skinner used the word complex systems behaving in lawful ways, but that doesn't mean we're nothing but machines. And does the machine analogy undermine our spirituality and our humanity? The analogy is perhaps dangerous, but it has some features that are found in Christian teaching. And my spirituality and humanity depend not so much on a disembodied Neoplatonic soul as on my relationship with God, who created and loves my embodied soul. So there I am.
Thank you very much, indeed, Peter. Well, I'm sure there's plenty of questions and hands going all over. So right at the back first. We'll start at the back and work forward. Yes.
Maybe I missed it, but there's one aspect of the analogy that seems to be missing in all this discussion, and that is machines need operators. So if you have a washing machine, for example, you need somebody to push the buttons, load the machine, and turn it on. Or if you have a computer program, the program has an operator that actually uses the program. So the idea of humans as being machines, this is the whole relationship between a machine and an operator.
Could you just summarise the question?
So he pointed
yes.
out that normally when we talk about machines, we're referring to devices that need an operator. And I didn't refer to that. Well, I agree. In principle, you could have robots that were autonomous. I mean, if you take Skinner's definition, a lawful system, sorry, an organized, sorry, a complex system behaving in lawful ways, then that would be compatible with an autonomous machine. But I certainly agree that in practice, all the machines we actually know require an operator. Yes.
Okay, yes, Ted. Yeah.
Thanks for introducing all these important issues. I'd like to talk about number 2, or have you expand on number 2. What about free will? You give preference to compatibilist or libertarian approaches. I'm a compatibilist, but my colleagues in Berkeley are incompatibilists. Would you mind going back to the slide where you have the hierarchy, starting with atoms, going up to social relations, the reductionism hierarchy?
I'm not very good with this.
Do you know what slide number it was?
No, but I get a rough guess. Well,
It's there at the end. Yeah, you go
because,
down.
yeah,
About
no.
25, 26, something like that. So.
I'm sorry to make this so complex.
No, it was 7.
Oh, you got it right there. You took good notes. Okay. Thanks, actually.
Yeah, so here we are.
Was it the hierarchy?
Oh, sorry, you wanted the hierarchy.
There's the hierarchy, you know, with
you
sort
know,
of
the
going
reductionism emergence hierarchy.
Oh, yeah, okay.
There you go.
Okay, that's
There
the
you
one.
go.
All right.
Yes.
Let me give you an incompatibilist argument and have you evaluate it. First, free will at the human level could not occur unless there was a physical pre-human precedent. Second, at the subatomic level, with quantum activity, we do have indeterminism. Third, atoms may be small, but they're everywhere, even in our brains. Therefore, human free activity is really a complex or emergent form of indeterminacy which is already there at the quantum level. This position is put forth by strong theists who believe in the incompatibilist approach. What do you think about that?
Okay, now it's a vast question, and a complete and total answer will be given by Tim Hunter at 11 o'clock. But I'd like just to focus on one of the points you're making. I don't think I can now discuss all the arguments that philosophers give for compatibilism or incompatibilism. But you mentioned the question of indeterminism. And that's the thing I've thought about a bit. And one position of many philosophers is to invoke Heisenbergian uncertainty. You know, because the quantum descriptions are a bit probabilistic. There is a little bit of indeterminism there. And in my view, the indeterminism is much too small, for example, to change a molecular bond in the brain. It's too small to affect most things that are going on in the brain. Whereas if you consider the function of a given nerve cell, it's got water molecules that are bouncing around in a way that's not controlled just by thermal energy. Now, this was a thing that was not discussed by David yesterday, but we do know that although the genes control a lot of what's going on in the cell, They don't control everything that's going on in the cell. They don't control the individual movements of water molecules, for example. And many events in the brain, like the diffusion of transcription factors and things like that, depend on just these random diffusion movements. Now, if you compare the energy associated with a water molecule that's bouncing around in the cell, it's about 1,000 million times greater than the energy that can be invoked by Heisenbergian uncertainty. And I think that the brain is designed, well, cells are designed to be resistant to this thermal energy, to this indeterminism. The cells work correctly, reliably, despite this indeterminism. And so if you've got a cell that's designed to be resistant to the thermal energy of water molecules and other molecules that are bouncing around in the cell, you're on difficult ground to invoke a useful form of indeterminism due to Heisenberg at a level of 1,000 million times smaller. Look, I'm giving a very short answer to a very big question, but that's my position.
If I understand you, you're saying that the indeterminate activity at the quantum level simply is not significant enough to have an impact at the level of activity in the brain. Is that right?
That's my opinion.
Yeah,
I mean, some people
okay.
disagree, but that's my opinion.
This, what Peter just said is published as an article in Science and Christian Belief. It might even be on the bookstall. I think it is, if you're interested in reading more detail. Yes, the back, and then I'll come forward. Yes.
Do chimpanzees have free will? And if not, what observation could an intelligent extraterrestrial make to confirm that difference between us and chimpanzees?
Can you
Yes,
repeat
the question is,
Yes.
do chimpanzees have free will? And what observations could an extraterrestrial make to determine whether or not chimpanzees have free will? Well, I, as a compatibilist, libertarians would say that my notion of free will is a very inadequate notion of free will. But when I choose coffee rather than tea, I'm not invoking something very mysterious. I choose coffee because I just happen to desire coffee. And I think that when a chimpanzee chooses a banana rather than something else, we could consider that a form of free will. And what could an extraterrestrial do? He could do experiments to try to work out if chimpanzees chose the food they actually wanted to eat.
The difference must be our capacity to not act in accordance with one's desire.
Oh, so free will to you is the capacity to not act according to one's desire. So in the I was giving exactly the opposite definition, that free will is the capacity to act according to one's desire. But I think what you're invoking is the notion of different levels of desire. So maybe I want to punch someone in the face because I'm angry, but at the same time I have an ethical principle that I don't want to punch people in the face. And so then you're starting to get complicated and introduce the notion that true freedom would be the capacity to allow myself to act according to my ultimate principles and not my immediate desires. Okay, then that's getting sort of philosophical. And of course then you could build a whole hierarchy of different levels of desire and letting the more noble desires somehow win out against the more basic ones. So I'm afraid I don't know enough about chimpanzees.
Rodney, question.
Yeah. Well, mine's related to Ted's in a way. This looks as though all the causation is going one way, from the atoms up to the social relationships. And even with that analogy about the sign, it's the macro level things going on that determine the sign and the way it's expressed. I mean, the fact that there's bubonic plague or whatever it might be and people are dying, you want to convey that. And so the causation is downwards. And I wonder if you have any room, for these higher level structures and so on, having a downwards causation effect, like Nancy Murphy and people would say.
So Arthur Peacock.
Yeah, Arthur Peacock and others.
So this is a major area of philosophy, the notion of downward causation, because it's certainly true that when scientists understand causation, we're mostly thinking about upward causation. We explain how a molecule works in terms of the different atoms that compose it. We explain how a cell works in terms of its underlying biochemistry, and so on. To what extent can one have downward causation? Now, I'm going to be very naughty here, because Tim O'Connor told me that this is one of the main subjects of his talk. Is that right? I mean, and I think it's best to leave it till then. But for two reasons. Firstly, he'll have more time to devote to it, but also he's more expert on this very deep philosophical question.
Okay, yes, there, and then, please, yes, first, yes, thank you.
I think I'm wondering about this gentleman's question in terms of Christianity. When we talk about free will, what do we mean? Do we mean, like you were saying, I want to do something, but I can restrain myself from doing it? Is this a freedom from that, being not being able to constrain oneself, being free to constrain oneself? Does that make sense?
Well, yes.
You summarise the question, maybe.
So she's wanting us to come back to the question of Martin Frame about freedom to exert restraint, so freedom for self-control and so on. Now, I mean, I could have had a completely different approach. I could have given a talk on the function of the brain regions that are involved in self-control. And we do believe that the frontal cortex is very much involved in self-control. And there was, for example, a school teacher somewhere in North America who was a perfectly respectable school teacher for many years, and then he started to behave in ways that were against his own ethical values. He started to read pornographic literature, child pornography, and when he started to behave incorrectly to his own adopted daughter, his wife called the police, he was put in group therapy. But he was expelled from group therapy because he was just proposing sex to everyone. And so he was going to have to go into prison. And the day before he was meant to go into prison, he turned up at the hospital for two reasons. One was he said he felt he was going to rape his landlady and couldn't control himself. And the second reason was he had a headache. And they did a brain scan, and they found an enormous tumor in the frontal lobe. They removed the tumor, and he again had the ability to control himself, to behave normally. Over the next year, the urges, the interest in child pornography, and all the rest started to come back. They examined him again. They found that the tumor was growing back. They removed the tumor a second time, and on that second occasion it was successful. He had no more urges. He became normal again. So we clearly don't know the details of what's going on in the brain when we exert self-control. But I agree with you, and I agree with Martin, that the full notion of freedom implies the freedom to exert self-control. And I'm sorry, I can't say much more about that now. I mean, that would be like preparing a whole new talk. Now, as for the chimpanzees, they have a much smaller frontal cortex. So I can well imagine that when it comes to exerting restraint and self-control, the chimpanzees are less good than some of us. But But I'm sorry, I can't say much more, although the question is very important, clearly.
There's a question here, please. Yes.
I really wanted to pick up on Rodney's point, in the question before about downwards causation. And certainly there are instances where that can happen. And in the field of epigenetics, which is factors that act upon the DNA to change whether a gene is expressed, switched on, but without causing a change in the DNA sequence itself. There was a study done a couple of years ago in rats, and good maternal behaviour in rats involves licking and grooming the young. And they actually studied the promoter, the switch of one of the genes in the brain, in the rat brain related to stress. And there were molecular changes on the promoter of the gene that were involved in good maternal behaviour. The molecular changes appeared in the offspring, and that affected their own maternal behaviour when they grew up. So yet the social relationship between the mother and baby rat had actually had a physical atomic change on the gene promoters, and very similar results have been seen in they studied human suicide victims, and they classed them into those who had been abused as children and those who hadn't. And again, the same sort of molecular changes were seen. So certainly there can be downward causation that's been shown.
Okay, look, I think I'm going to summarize that very briefly. She points out that behavior, for example, social grooming, that sort of thing, social interactions, can affect much lower levels of activity, such as transcription. And that is clearly the case. But I think the question of downward causation to philosophers is more complicated than that. But it's certainly true. And what Fiona is saying. But I mean, as you listen to my talk, as I give the talk, our brain activity is of course going on. That's involved in understanding, and as the cells get activated, that involves the entry of calcium and sodium and so on. And just this behavior is going to lead to changes in transcription. I mean, it will just the brain activity will activate transcription factors, which will affect transcription. So the production of messenger RNA, well, RNA and then messenger RNA from DNA is constantly being affected by our higher level activity. That is absolutely clear. But when philosophers get discussing the problem of downward causation, there is a very complicated debate about what can we really deduce from this? In what sense is it right to call this causation downward? And so I entirely agree that it is a complicated matter. For example, an American philosopher called Kim wrote a very influential book attacking the notion of downward causation. Yeah.
Please, yes. Yeah, Ren, yes.
So I have a question about compatibilism. So if you're a compatibilist, you think that determinism is true. So you hold that, for instance, that given the laws of nature and given the state of the universe millions of years ago, we couldn't have done otherwise than we did. So these laws of nature and these initial states of the universe entails, for instance, that you at this very moment want something. Well, insofar as there's nothing that impedes you for doing what you want to do, insofar you are telling us, I am free. I have free will because there's nothing that impedes me, nothing that prevents me from doing what it is that I want to do. Now my question is, if this is free will, and if this is determinism, then isn't it very hard to squeeze into that picture any notion of responsibility? You are not responsible for any choice that you ever made because you didn't make any choices. The only thing that really counts on this account of free will is whether or not there is something that impedes, that forms an impediment for what it is that you want. And I find it very hard to squeeze into this picture any notion of responsibility.
Okay.
Yeah, summarize the
So,
question.
is that we've got a philosopher here who's attacking the notion of compatibilism. And he's extending the notion of determinism not only to what I was discussing now, the determinism within the brain, within the body, but within the whole universe, right from the moment of the Big Bang, I think he said. So, and in answer to one question, I mentioned that I thought that Heisenbergian uncertainty would not be sufficient to overcome other control devices that are occurring in the brain. But I wasn't wanting to apply that to everything that happens in the universe. I mean, we've got a complicated subject here, how the brain works and a bit of philosophy of free will. And then we got how the rest of the universe works as well, just to keep things simple.
Well, since you were referring to this philosophical debate, and this is the standard understanding of determinism.
Okay. Well, I mean, I agree that we therefore have an even vaster question about the determinism of the rest of the universe. And I actually don't pretend to be expert about the universe. Yeah, we got an expert here, but I mean, one could argue that.
Isn't the point that, that your state now is predetermined by from before you were born, essentially?
Yeah, and perhaps okay, but perhaps the whole universe is not deterministic. Perhaps because of Heisenbergian uncertainty, there really is an indeterminism that matters for the whole universe. For example, I mean, does everyone know about Schrödinger's cat? Okay, so Schrödinger's cat is a macroscopic object, and Heisenberg, just an indeterministic event, like a radioactive decay or something, could kill Schrödinger's cat, and so major things in the universe can perhaps be indeterministic.
Well, so let's leave the cosmos out and think. Well, there are certain my brain activities are such, or your brain activities are such that at this very moment there's something that you want. And now you're telling us that you're free insofar as what it is that you want isn't. There's no impediment for you for actually doing it. Mm-hmm. So my question again is, if this is free will, and if this is brain determinism, if you accept that, and if you advertise yourself as a compatibilist, I suppose.
Yes.
You must accept some sort of brain determinism. So if this is brain determinism and this is free will, does this leave room enough, or does it leave any room for descriptions of responsibility?
Okay, I mean, essentially the argument that he's giving is the simple consequence argument by Van Inwagen. Will you be talking about the consequence argument of Van Inwagen?
I thought I'd just mention it as a quick rebuttal.
Okay, that'll be just a quick, okay.
I was just going to add that in.
Look, I think, I mean, okay, so the argument is that if you can trace back a mechanism from the before I was born and say that everything that happens, everything I do now was determined even before I was born, I'm certainly not responsible for what happened before I was born. So in what sense can I be considered responsible for what I'm doing now? And of course, it's not a nice situation for a biologist to be arguing with a philosopher on a philosophical question. So, I don't pretend to have an answer. And the fact is that the best philosophers in the world are still arguing about this, and they disagree. So, a few years ago, like 30 years ago, almost all philosophers were compatibilists. And so I could have said, well, look, just all the philosophers agree on this, so go away. the problem is solved. But the trouble is that since Van Inwagen and other people wrote their Van Inwagen's book and other people's papers on the consequence argument, the whole debate has come alive again. And now there are a lot of incompatibilists, and it's an enormous debate. And I'm sorry, but I don't think I can solve this debate now. And maybe Tim will have something useful to say, but I can only accept that although I am a compatibilist, I don't claim that I could win an argument against an incompatibilist philosopher. And the debate is still alive. Yeah.
Great. Okay, another question. Yeah, yes.
So
yes.
just following up on
Yes.
this, and speaking as a physicist who doesn't know a fiddly squat about biology or brains, I mean, we know there are many systems in the physical world which are unstable, and they certainly are so sensitive to initial conditions that there is no way that you can prescribe their future evolution within the constraints of quantum mechanics, quantum uncertainty. So you have, say, displayed a preference or perhaps the hypothesis that there are also in the brain, as there are in other physical systems, systems that are stable, which are therefore not indeterminate down to the quantum level. But I'm puzzled that you assume that all of the brain, or all of the creature, for example, is necessarily deterministic in that sense, since we know in the physical world, not in the biological world, that there are many systems that are indeterminate at the, down to the quantum level, and that's, of course this is all bound up with chaos and so forth, although that's really a red herring, really. It's to do with stability, it's to do with convergence or divergent stability or instability. So why do you prefer the stable view? I mean, certainly there are stable systems in the creature and in the brain, but there may also be unstable systems.
Okay, he's talking about stability, and I feel a bit happier here, because I have actually worked on questions of stability and instability, and done a little bit of mathematics on this. And as he said, chaos is one example of instability, systems that are very sensitive to minor fluctuations. Now, actually, the argument I meant to give, but I said too briefly, was that because there are indeed, exactly what you say, unstable events like chaos. Simple is not the word, but let's take the example of chaos. The water molecules bouncing about in a cell are considered to be essentially chaotic. So you've got chaotic motion, you've got chaotic things, events that are highly sensitive to very minor fluctuations. Although, on the classical model at least, these will be deterministic. They're deterministic but unpredictable. Now, one of the points I meant to make was that the brain, this chaos involves energies that are much, much greater than Heisenbergian uncertainty. So my point is that the brain behaves at least reliably, but perhaps not deterministically in the sense of determined by genes plus environment, but reliably in the face of this chaos. So you could argue that the behavior of the brain is deterministic but unpredictable in the sense of chaos. I mean, approximately predictable, but undeterministic. And actually, that's exactly what I think, so I exactly agree with you. I think that if you get two genetically identical animals that are reared in identical conditions, and then you study their brains in detail, they are not exactly identical. And I think this is because of these events that are essentially chaotic or at least unstable, occurring within cells, like the thermal movement of water and other molecules. And this does mean that there is not total determinism, if by determinism you mean determinism by genes plus environment, and there's not total predictability, Although nevertheless all this obeys the laws of physics, and because Heisenbergian uncertainty is much, much smaller, one can consider the laws of physics at a classical level without getting into complexities of quantum physics.
Yeah, just to follow up a little point, I mean, take genetically identical mice colonies. They all die at very different ages, kept in ostensibly identical environments and all the rest of it. So, I mean, just as an example, you know, there are many, many biological examples. I wanted to ask Peter a question. I mean, one of the curious things, it seems to me, is people invoking Heisenbergian uncertainty or indeterminacy of some kind in talking about moral responsibility. Now, it seems to me that if we are morally responsible, as I believe we are, I mean, that's the last thing you should invoke, you know, sort of randomizer. If you have a randomizer, then that doesn't seem to be a very good underpinning for moral responsibility. So do you want to comment on that, maybe?
Yes, I mean, because this is the thing that the critics of libertarianism have often raised, and Galen Strawson, who's professor of philosophy at Reading, gives the view that determinism is incompatible with free will, and indeterminism, for the reason you're given, is incompatible with free will. So bad luck. But nevertheless, philosophers tried to find solutions to the problem you raised. And one solution that is, in my mind, a bit contrived, but ingenious and very well argued, is the proposal of Robert Kane, who proposes that when we have a sort of moral struggle, we can't decide, should I punch my mother-in-law or should I be nice to her? And when we just can't decide, we have a struggle, then a random event there would not make things worse, because in any case I'm totally undecided. It's 50% for punching her, 50% for being nice to her. And so if in that case we have a random event which decides whether I punch her or not, then the consequences of that random event will feed back not only on the nose of my grandmother, but also on my other parts of my brain that will determine how I behave in the future. So that's the sort of very complicated and contrived way in which some of the very best philosophers try to get over that problem.
Good. You know, I have a desire for tea. Does anyone have a desire for coffee? So I think we should really thank Peter for getting us off to a great start.